Alright.
I'm gonna get pencil.
Okay, one last thing in 5.2. Everything that we've done so far in 5.2 has been on the unit circle. So the only thing that's left for us to do is, what if our point is not on the unit circle? So the only thing that's different,
You can't do it.
okay, good question. How do you determine that? Well, let me show you a problem here. Well, let me say this first and I'll come back to that. Okay, so if it's not on the unit circle, the only thing that we have to do differently is take into account the radius. Because we knew that if it was on the unit circle, what was the radius? We knew that. So the only thing we have to do is take that into account. So instead of the sine of theta just being y, the y coordinate, the second coordinate, then we're going to put it over r, the radius, and I'm going to show you why in just a second. When I do this first problem, when I work through it, I'm going to show you why that's the case.
Wait, the radius is 1 though.
But we're not on the unit circle anymore.
Oh.
We were on the unit circle, which is why we didn't have to worry
What
about
did you
that.
say Y was?
So it's the radius of
The
what?
y coordinate of
Oh,
the
okay,
point,
okay.
The radius of what?
the circle that we're on. I'm going to show you in just a second, okay? Okay, so cosine, instead of it just being the x coordinate, the first coordinate, now we have to take into account the radius. And again, I'm going to show you a picture in just a second to show you why this is. Tangent is sine over cosine, so y over x. Just like before. And so then the reciprocal of sine is cosecant. So we flip that upside down. The reciprocal of cosine is secant. This is not new information. We're going to flip that upside down. The reciprocal of tangent is cotangent. We're going to flip that upside down. So the only thing that's new here is if we're not on the unit circle, we have to take into account the radius. Because it's no longer 1. It's not on the unit circle.
Alright, so you said that tangent was sine over cosine?
Uh-huh.
Like, does that work like with trig too?
Uh-huh.
So like if you wanted to...
If I were to put y over r over x over r, it would still work out.
So like if we were talking about triangles instead of circles, like you could find tangent by just doing sine over cosine?
Yep.
Okay.
Okay, so let's see, here's the first, it's actually example 12 in your book. That's where we're at, example 12, but it's our first one today. So we're going to find all 6 trig values for an angle whose terminal side lies on this point. So this angle starts at 0, and I'm going to kind of sketch in the axis here. And the terminal side, what's the terminal side?
So that's how the angle is.
Where it stops. So the point 4, 3. 1, 2, 3, 4. 1, 2, 3, 4, negative 3. So this angle starts here, and it goes all the way around here. So that is the theta that we're looking at. All the way around here. Okay, so I need a different color. So in order to figure out what the values of all 6 trig functions are, what value are we missing? The radius. Question?
Yeah. So for theta, we don't use like the little, we use everything except for the angle then? Like you're making a circle except for that little part you cut out? Or?
Yeah, that's not really going to matter in a second because we're not actually looking at the angle. We're looking at the sine of the angle,
Oh,
the
okay.
cosine of the angle. So
No.
that's really not that important. But yes, you're right.
Everything except for that angle?
Right.
Oh, okay.
Okay, so really, how am I going to find the radius? That's the only thing that I'm missing so that I can set up all these values. So the radius, well, do you remember yesterday when we were doing the unit circle, I drew in a little right triangle. What's this side? That side has a length of 4. This has a length of, it was negative 3, so it has a length of 3. So can you tell me what the radius is going to be this time? 5. And of course, if it's not a Pythagorean triple, you can use Pythagorean theorem. So my radius is 5. Okay, we're set now. That's all we got to do before we can fill in these values. So the sine of theta is what? this over the radius, -3/5. And if you look at this, theta sine is opposite over hypotenuse, so that's why these new ratios work the way they do. Cosine of theta is going to be 4/5. The tangent of theta is going to be sine over cosine, -3/4. The only part that's new here is that you have to find the radius. So then the reciprocal of sine, what?
How'd you get that?
Right here, this is a right triangle. That side, that leg is 4, that leg is 3, so the hypotenuse is going to be 5. 3, 4, 5 is the Pythagorean triple. But if it weren't a triple, you could plug into the Pythagorean theorem. So the cosecant of theta is -5/3. The secant of theta is 5/4, and the cotangent of theta is -4/3. The only thing that's new is that you have to take into account that radius.
If you plug in the Pythagorean theorem and it's not a triple, and you get a decimal, are we supposed to go to? Are we gonna get any like that, or,
I'm sure you will.
so are we gonna round
Do
to?
we just like leave it as a radical like we did yesterday
Years?
and rationalize it?
Simplified, radical, and rationalized, yes. Okay, so that's all that's new.
That's all?
We are finally finished with 5.2.
This,
I'll go with this.